on the axis we have to determine. So as such, we don't have any formula. So shall I assume that a ring made up of the point mass? Okay, let it be dm. First we'll calculate what is the potential on the axis due to this point mass. And moreover, potential is what? It's a scalar quantity, no? So don't write dv here. Don't show like this, dv like this. I think you should not do dv, you should not show, because potential is scalar quantity. So this will be try to avoid. Just at that particular point P, what is the potential? So at point P, the potential is given by dv is equal to minus g dm by r. What is the r? The point mass is at a distance r. G dm by r. Further, so now what is r? You take any point on the ring, it will be at a distance r only. So what is the potential? Given by just simple formula gm by r. So what is this? What's wrong if you get answer in a simple way? And what is r is equal to? Root of r square plus x square. This is on the axis, or potential at point P. You write like this. Potential at center I want minus gm by r. Put x equal to 0, problem solved. So what is the potential at the center of the ring? Minus gm by r. So if you plot the graph, where it will be maximum negative, means if I go for plotting the graph, it's a negative value, no? So therefore I'll show the curve in this region. Take it like this. This will be minus gm by r, and afterwards it will keep on decreases. Why the curve should be like this? So this is the expression for potential. This is r, and what is the value of this? Minus gm by r. So as r increases at O, what happens will be maximum. How much? Minus gm by r. And as x increases, I think you know from mathematics, the potential keeps on decreases. Don't show here. If you're going for magnitude, you can show the graph like this. Since the negative value, no, so therefore I just took that here. So there's a variation of potential due to this one, due to ring. So on the axis, what is the potential? Minus gm by root of r square plus x square. Okay, now what was our main primary idea? Like I want the interaction potential between the body and the particle, no? So we have already for a ring and a rod. Let's see that what I can further bring the conditions here. So let me start with this one. Let me introduce today only. Suppose say there's a, first we'll take the, let me draw the ring. Now let the mass of the ring be m1. Delta of the particle, let it be m2. These are this x. I want interaction potentially between the ring and the particle. Straight away, let me directly get into the idea rather than going here and there, that one. So what I do is like, I will compare now. I will go back to the original thing. What is the interaction potentially between the, this is, I'll come to the question. Okay, let me go back here. These are the 2 point masses are there, let's say. The separation is R. So there's a point P, at which point mass M2 I put it. What is interaction potential? You write it. G M1 M2 by R. This is what I think we know. What is the potential at point P due to point mass M1? Will you write like this? Minus G M1 by R potential at. So what is this? Potential at point P due to M1 only. So in place of G M1R, what you can write it? Vp into M2. Getting some idea now? So what is interaction potential between 2 point masses in terms of what I'm bringing, in terms of potential and this particular. But already we know formula. See, I'll extend this idea now for this one here. I want interaction potential between the ring and the particle. So where the particle is kept at point P. So what shall I do now? The interaction potential between this, I'll assume that particle present in the field of the ring. Then what is the formula you're going to write it? Interaction potential between the ring and particle is equal to potential at point P into point mass where it is kept. Do we know potential at point P? Just now we derived. What is the formula? Gm1 by root of r square plus x square. Now tell me what is your equation will be now? This interaction potential between the ring and particle. See, all small ideas, tidbit ideas, nothing big. Interaction potential G between ring and particle. Now, so for any body, if a particle is kept nearby any body, how to calculate interaction potential? Tell me what I should find out. What I should calculate. Calculate potential at that point where point mass is kept. Then potential at point where point mass is kept into mass of the point mass will give interaction potential between the body and the particle. I think there's a core general idea which our all numericals will revolve. This week what will happen, you can see that everywhere I'll be talking about conservation of mechanical engineering, because what is the gravitational force, conservative force. Then how to write the energy, what all form energy, kinetic and potential. How to write potential, this is the idea. This whole week what happened, it just stands on this particular stand, like a basic, the idea that one. What all, any problem you do know, if point masses, okay, you are going to take this formula. If the body and the point mass is there, you are going to take this formula. This is the thing. So again, I'll stick on to what is the potential, how you define work done per unit mass. I think nothing wrong, no? From there. So what all that point masses ideas are there, no? They are the core central ideas. From there, what happen? All other ideas we will generate. Able to get this? So means like a, I will also write like this. Here, let me write Q. Is it correct? So what is VQ? Potential at point Q yes, fine, no problem. See, like a questions comes, okay, fine. So in more than one options, no, they define like this. The interaction potential G at point P can be defined as potential at point P only due to M1 into M2 will be the interaction potential. It's correct definition. Or potential at point Q only due to M2 into M1 will be interaction potential. Both are same, because I think finally we'll end up the same answer. Means like a I'll find out first. I'll assume that this particular body present in the field of the point mass. I'll find out the potential. So what you should do now here, you should calculate potential at this particular point on a ring due to this. called du, then integrate. Look at the interaction potential change. Nothing wrong. This is one easiest way. Can you assume that the ring present in the field of point mass is? So in that case, what you should do? Assume a small element here, calculate interaction potential, integrate, you'll get the same answer. Getting the idea? This one? Okay, after this, okay, now so definitely now tell me like what is very important for different shaped objects. If you know potential surrounding them, I think you'll be in far better position. Like how already you came to know the gravitational field. Now I'm asking you to calculate also potential. What are the different bodies already? Ring I shown, point mass, rod you came across. Then after this, what you should do for a disk, solid hemisphere, for a sheet, solid sphere, then thin shell, spherical shell. For these objects, if you know the potential, yes, you can manage here. Let me go for the thin disk. Potential due to